discussed yesterday? Yesterday we discussed about OLTP versus OLAP. OLTP versus OLAP. What is OLTP database and those properties, all 10 properties we learned. What is OLAP database, and we discussed all the 10 properties we discussed. There is very important interview question. In each and every interview they will touch what is OLTP database, what is OLAP database. Because those two are fundamentals, for database, right? Perfect. Now, today we'll go for history of the data warehousing, how it is came into the existence, and all will try to understand. If you see the history of the data warehousing, first initially before 1970, there was no automated decision making system available. Total data we used to store in file formatted things, right? So before 1970, there is no automation system. We used to store everything in the file system only, file formatted system. Even still some government offices, small government offices, they are following what, sir? File format only. There is a reason to provide data of birth certification, they are taking 3 or 4 days. SLA, service level agreement. Okay. Right. Now let us go for next one. Let us say this one. In 1970s, before 1970s, totally files only. In 1970 year, what happened is we have mainframe system. In that mainframe system, we used to store the data and we used to take it. After 1970, then we went for 1980s. In the 1980s, we used to collect different data from different sources, and we integrate in the area that is called as what, sir? DBMS, Database Management System. With that also we are not happy. Then we moved on to next one that is called as what, sir? In 1990s, islands of data were copied into a common location that is called as data warehouse was born. So now data warehouse came to existence from which year, sir? From 1990. Almost it is 22 years old. Okay. Now, in the 1990, we have 2 guys. One guy is called as Bill Inman. Other one is called as Rolf Kimball. These 2 guys proposed the new term that is called as data warehouse and this process. That is the reason these 2 guys are called as fathers of data warehouse. And these 2 guys are trying to define the data warehouse in this fashion. If you see, first we'll go with the Bill Inman. Yesterday, while defining OLTP versus OLAP, we underlined some of the points. One is database. OLAP database is what, sir? Subject-oriented database. It is a non-volatile database. It is a time-variant database. Next what, sir? It is an integrated database. These 4 properties yesterday we understood. Based on these 4 properties only, is trying to define his definition. A database is a subject-oriented and integrated and time-variant and non-volatile collection of data that is called as what, sir? Data warehouse. That means all we will check is, suppose this is, I am saying this is my database, sir. Please check this database is suitable for data warehouse or not. What you will check is this database is subject-oriented or not. This database is integrated or not. This database is non-volatile or not. This database is time-variant or not. All these 4 properties are satisfied by this database. Then you can say this database is what, sir? Data warehouse. This database is data warehouse. Right. This is totally, if you see the terminology, technical terminology, or it is a business terminology. It is a technical terminology. Subject-oriented can be understood by only technical people. Yesterday, if you not attended class, then you don't know what is subject-oriented. You don't know what is integrated. You don't know what is non-volatile. You don't know what is time-variant. Yesterday, you attended my class. That is the reason you know the 4 terms, right? This I can say it is a technical terminology. It cannot be understood by a business person. And to understand business way, Rolf Kimball come up with one more definition. That is what, sir? Transactional data specifically structured for query and analysis. Whatever transactional data we have in our database, that only we are organizing. we are arranging, we are organizing or we are arranging in such a way it will be useful for business analysis. It will be useful for business analysis. That is the reason whenever you are providing some official document to the business, whenever we are providing some official document to the business, we will not use this definition, sir. Because if you use this definition, no one can understand. That is the reason we'll go with the normal terminology, business terminology will go. What do you mean by analyzing your business means, sir? If I ask any question, it should give the answer. If I ask a question, who are my best customers? What are my best products? Where is my good business? When I have my good business, that means what, sir? It is answering who, where, what, these all answers, right? I mean to say, if you go for one document, official document of the client, real-time reports, let us say Fox client, this document we provided to client Fox to tell about what is my data warehouse is doing for you. What is my data warehouse is doing for you? To understand that one, I given my thing. If you see here how we provided the definition of the data warehouse is like this we provided. My data warehouse application will support, these all are the 4 questions. These all are the 4 questions. If you ask a question, what are we selling? Then you give all products. Then if you ask it is, let us say, to whom are we selling? Then you give all the answers. If you ask, let us say, when are we selling? Then you give the answers. If you ask, let us say, how are we selling? Then you give the answer. If you ask, let us say, where are we selling? That means reason, geography, location. The location also will give the answer. This can be understood by business user or not. Anyone can understand this one. Anyone can understand this one. If I given technical terminology that is subject oriented, integrated, non-volatile, time variant that you only can understand, no one else can understand it. Because as a technical person, you know what is the exact meaning of subject oriented means. Correct. So this kind of document we used to share with the client, what exactly our project is doing. Am I clear? So Ralph Kimball definition is very user friendly to understand the what exactly data warehouse. This is useful for the technical persons. And these 2 definitions written by me to understand properly, I given here conceptually. Conceptually means it is a second-hand data that originates in other corporate applications or some external data sources. Why I am saying this as second-hand data, sir? Whenever we went to the one ATM and we are doing some transaction, the data is directly coming to the data warehouse? No. That is coming to where, sir? OLTP database. From this OLTP database, we are loading data into OLAP. From this OLTP database, we are loading data into OLAP. That means, can I say it is a second-hand data? It is a second-hand data. Next, formally we say standalone repository of information integrated from several heterogeneous operational databases. In our data warehouse, data is coming from only one OLTP, sir? No, right? It is coming from n number of OLTPs. As it is coming from n number of OLTPs, we can say it is what, sir? Heterogeneous application database. Here, these databases are divided into 2 types, sir, basically. One is homogeneous, other one is heterogeneous. Homogeneous, other one is what, sir? Heterogeneous. Homogeneous meaning, yes, similar one. Let us say I have 2 databases. This is Oracle database 1, this is Oracle database 2. Oracle database 1, Oracle database 2, 2 databases are available. Both the properties wise similarly it is there or not? Properties are similar, so this is called as what, sir? Homogeneous. This is, let us say, Oracle database, this is, let us say, SAP database. Oracle database understands SQL language. SAP database will not understand SQL language, will understand what, sir? ABAP language. So properties wise both are similar, sir? No. Properties wise both are not similar. These 2 databases are called as heterogeneous. So what I am trying to say is 2 similar databases are called as homogeneous. 2 dissimilar databases are called as heterogeneous. So we are loading data into data warehouse, not only similar databases, it is from the heterogeneous also. That means dissimilar database also we can use it. Am I clear that point? Yes. Now, if you go for the data warehouse or DB flow, Data warehouse or DB flow. Any questions on this data warehouse in definition, sir? You need to deliver these two definitions at least. Whatever I written, it is not okay. If you are not able to understand or if you are not able to deliver it also okay. Whatever these guys written, you need to understand because everyone knows that one. These two things I written with my experience, whatever I have in my projects. Am I clear, sir? Right. Any questions on these two definitions? You are open to ask. Any questions? No. Let me go for next one. Data warehouse or DB flow. What do you mean by database, sir? What do you mean by database? It is some hard disk space, right? It is some hard disk space when one database is there. In the database, we are naming that as what's that? ORCL. Normally, ORCL is the Oracle company's shortest name. You know already people know or not? You know, right? ORCL is nothing but Oracle company's shortest name. In the share market, it is registered as what's that? ORCL. The share market is registered as ORCL. Right. If you want, I want to show that one. That is also required going forward. If you take this one, how this name is came is in the market is registered as what, sir? ORCL. In the market is registered as ORCL. That's the reason whenever you install Oracle database, by default name what is coming, sir? ORCL. ORCL is nothing but Oracle official name. Oracle share market wise official name it is. That's the reason the share market is going like. Perfect. We are least bothered about that one. What I am trying to tell in this point of time is database is nothing but what, sir? ORCL. One of the database name is ORCL. Inside the database, what will be there? Inside the database, what will be there? We have n number of schemas, right? Schema means what, sir? Start is one schema. Supply to is one schema. Whenever you create one username, with that username, automatically one schema will be created. With that username, automatically one schema will be created. That's how the start is created. That's how the supply to is created. Supply tree is the schema which is designed by RR ITEC. We are going to deliver all our OBIEE training using supply tree. That means we are not using simple things like employee table, DEP table, sir. Okay, we are going to use our own data for all our deliverables. Fine. Next, in one schema, what will be there, sir? N number of tables will be there. One of the table is, let us say, employee table. Second table is, let us say, DEP table. In one table, what will be there, sir? N number of columns, that is employee number, employee name. In column, what will be there, sir? Actual data will be there. Actual data will be there. These all names, whatever you are seeing, those things are called as metadata. What is called, sir? Metadata. This is the new term we got, right? This is the new term. To understand that new term, let me give some example. I am giving some example. Let us say I written here, let us say ABC, and I am writing here, let us say XYZ, and I am writing here, let us say 100. This is, let us say 200. I written like this. Now, what is my question is, can anyone comment on about this data? If I ask a question, what is ABC? Are you able to answer that one? ABC may be human name. ABC may be product name, ABC may be village name, ABC may be any other thing also. We are not able to comment about it. Now, I am writing something here, let us say, I am writing E name, and I am writing, this is, let us say, salary. Now, are you able to comment about it? ABC is the name of the employee, 100 is the salary of the employee. This also data or not, sir? This also data or not? But this data has no meaning without this one, right? This data is giving meaning to this data. This data is giving meaning to this data. That's the reason this data is called as metadata. Metadata definition is data about data. Metadata is a data. That means metadata is a data. It talks about what, sir? Something else. Metadata is a data about data. I can give some examples for metadata as column names, table names, column data type, column size, your database name. These all things will be falls under where, sir? Metadata. Whatever values we have, that means A, B, C, X, Y, Z, 100, 200, these values are called as what, sir? Data. In our database, we have two things. One is metadata, other one is data. Whatever I given here, this chart that contains only metadata. That means your database name is metadata, your schema name is metadata, your table name is metadata, your column name is metadata. Inside the column, whatever we have the values, those values are called as what, sir? Data. Those values are called as data. Metadata definition is it's a data about data. Now we will start learning these all things. Let me start with from bottom. I think already we learned top part. Database. Database we learned or not, sir? How many types of database we have? Two types. One is OLTP database. Other one is OLAP database. One is OLTP database. Other one is OLAP database. Yesterday our total class is that only, right? We discussed about OLTP versus OLAP. These are all 10 points we learned. That means database part is completed. We need to understand remaining things. There is columns. Next what, sir? Tables. Next what, sir? Schemas. Let me start my lecture with the columns. Let us go for the columns. How many types of columns available? The number of columns available is, one is called as key column, sir. That is denoted in our OBIEE with the symbol called as key symbol. Second column is called as string column or descriptive column. That is denoted with in our OBIEE with this symbol. Third column is called as measure column. That is defined with this symbol. So totally how many types of columns we have, sir? 3 types of columns are there. Now we have one challenge in front of us. If I given one column to your hand, you need to identify that column is what type of data. Let us say I am giving one column to your hand. Let us say I am giving some data here. Let us say A, B, C, X, Y, Z. What is this column type, sir? What is column type? String column, no issues. Why? Because by seeing the data itself, it is saying string or descriptive, no issues. Now the problem will start. Suppose I am giving here some data. 100, 200, 300. What is this data, sir? It is a key column or it is a measure column? How you are saying? It may be key also, right? 100 maybe I can say customer number. 200 I can say customer number. 300 I can say customer number. Yes or no? Or I can say department number also. No one will say this is the key column or measure column. It is a dilemma. There is ambiguity. It may be anything. Now, how to identify the key column or measure column is based on the functionality. That functionality is, let us say I am giving this title as employee number. I am giving this title as, let us say, salary, and I am giving this is, let us say, 1,000 or 10,000 I written. 1,000. This I am saying as 2,000. This I am saying as 3,000. Like this I written. Everyone in the world is used to sum up these all things, right? Let us say I am doing here equal to SUM sum of these all things I am doing. Then what is my answer, sir? 6,000 I got. Anyone did you have chance to see people are summing employee number, sir? No. Why reason? Why they are not doing that one? Number is support sum also, right? Any number column supports sum operation. Why people are not doing? Why they are not doing is 6,000 is able to answer one of my business question. If I ask a question, what is the total amount I need to pay to my all employees? Then give the answer as sir, 6,000. Will it give 600 any answer for any business question? Is it a valid information? 600 I can say it is invalid information. It is not at all useful to answer any business question. It is not at all useful to answer any business question. Based on this point, I can say any number column, it is supporting some operation. It is supporting some operation and it is giving valid information. Then it is called as what, sir? It is called as measure. Otherwise, it is called as what, sir? Key column. That is the reason I written here. After summarization, a numeric column is giving valid information. That is called as measure column. Else it is called as key column. A number column. After summarization of a number column is giving valid information. That is called as measure column. Else it is called as key column. Now we have some logic in our hand. Based on this logic, you can identify data or not. Suppose some data column I given to your hand. Are you able to identify which is key column, which is string column, which is measure column or not? Yes or no? Yes. If you want, I will show you our regular RPD. Let us say some batch developed that one. Oracle Business Intelligence, BA Administration. I will open your juniors batch. Go to file menu, open, let us say offline B151 underscore EBA is your juniors batch. B151 underscore EBA is your juniors batch. Your batch number is B152. If you see here clearly, here I have some columns, right? If you see these all columns, either key columns are available or string columns are available. Next what, sir? Or measure columns are available. Apart from these three types of columns, anything else is available, sir? No. Anything else is available? No. That is the reason we divided columns of three types. One is key columns. That means that will be looks like this. Descriptive columns. That means that will be looks like this. Next what, sir? We have here dollars column that will be looks like this. Now we understand the columns, no issues. Let us go for next is what, sir? Tables. Can I define column in this way, sir? Combination of data or group of data is called as column. Combination of data or group of data is called as column. King, Scott, these are not employee names. That's what I am grouping these all things under employee name. So a group of data is called as column, correct? Similarly, a group of columns are called as what, sir? Table. A group of columns are called as table. If you go for the tables, in our data warehouse, we have only two types of tables. Mainly, we have two types of tables. One is called as dimension tables. Second one is called as fact tables. This dimension table in our OBIEE will be denoted with this symbol, sir. Fact table will be denoted with the symbol, this symbol. What is the difference, sir, between these two symbols? A number symbol is appearing, right? A number symbol is appearing on top of that one. That is the only difference. Am I clear? Now your problem is if I given one table to your hand, if I ask it is a dimension table or fact table, you should be in a position to identify that one, right? How to identify it? Very simple. If a table contains at least one measure column, then it is called as what, sir? Fact table. Else it is called as dimension table. That is the reason, if you see in my RPD, F1 sales is fact table or dimension table, sir? Fact table. Why it is fact table is because I have here measure columns. If you take here customers, this is fact table or dimension table, sir? Dimension, because I don't have here any measure column. I have key column, descriptive columns, but I don't have measure column. And I go for next one, let us say time also. Time has what, sir? Dimension table or fact table? Dimension table, because I have no measure column. Simple definition. If you have measure column, then it is called as fact table. If you have no measure column, then it is called as dimension table. Simple definition. Right, that is clear. Let me go for next one. Important one. That is what, sir? Schemas. We defined a group of data is called as column. A group of columns are called as table. A group of tables are called as schema. A group of tables are called as schema. All are interrelated. A group of tables are called as schema. These schemas are divided into three types. One is called as star schema. Second one is called as snowflake schema. Third one is called as constellation or mixed schema. Out of these three schemas, more used one in our data warehouse is star schema. What is that, sir? Star schema. Exclusively in our OBIEE, 100% will use only star schema. 100% will use only star schema. That means what, sir? No snowflake schema, no snowflake schema, nothing at all. We'll use only star schemas. Am I clear? Right. Let us go for that one. What do you mean by star schema properties and all? What do you mean by star schema properties and all? Let us go for the star schema properties slowly. First point. Observe this diagram, sir. Don't read any points. Observe this diagram. How this diagram is looking like? It's looking like star or not? Yes or no? Star means what? It should be circle. It's looking like circle or not? Yes, it's a circle. So in this circle, if you observe carefully, we have here one fact table surrounded by what, sir? This is one dimension, this is one dimension, this is one dimension, this is one dimension. Surrounded by what is there, sir? Dimension tables are there. So what I can say is organizes data into central fact table with surrounding dimension table. It is one of the property of star schema. So if you want to, if you say one group of tables is star schema, means that should compulsory satisfy this property. There should be only one fact table. There should be only one fact table and surrounded by what, sir? N number of dimension tables. Next point. Important. Each dimension row has many associated fact rows. Each dimension row has many associated fact rows. To explain this clearly, I want to go for next slide. Let us say this slide, observe, sir. This is taken from our OBIEE only. Here, what is the dimension tables are there, sir? Customers, products, periods. Next what, sir? Products. This is what, sir? Sales facts. This is fact table or not? This is what, sir? Dimension table. This is dimension table. This is dimension table. I taken some data out of it. This is what the data I have. This is what the data I have. If you take this is the dimension table, I have a row width. Yesterday we discussed about one extra component, that is OBIEE, Oracle Business Intelligence Applications, right? What is the Oracle Business Intelligence Application, sir? It is a predefined work. Oracle guide created for you and it is giving you as a predefined work. In that one, we have one of the, each and every table is created, right? Tables, all things will be created by Oracle guide and will give that structure to you. In that structure, each and every table contains the first column is what, sir? Row width. Row width is nothing but surrogate key. Row width is nothing but what, sir? Surrogate key. Or else I can say it is a primary key in our data warehouse. Surrogate key, or else is called as primary key in our data warehouse. Row width meaning is row underscore W stands for warehouse. W stands for warehouse ID. Row underscore warehouse ID. That means each and every row in the warehouse is identified uniquely using this row width. Am I clear this point? Yes or no? Yes. Now, I have here row width. This is the surrogate key, or I can say it is a primary key in our data warehouse. The full form of this one is row underscore warehouse ID. Similarly, I have here row width. Similarly, I have here row width. These all row widths are stamped in fact table. Stamped in fact table. What does that mean, sir? Fact table has no fact table keys is nothing but combination of what, sir? These all keys. I mean to say this record will be uniquely identified combination of these three things. And observe carefully here how the records are mapped here. If I take one guy, AK Parker. AK Parker is one of the customer name. AK Parker came how many times here, sir? Correspondingly 17023 is there, 17023 one time, 17023 two times. That means, can I say like this? One record in dimension table is mapped with two records in fact table. Yes or no? The probability is there or not? Let us say I entered into one hotel. Morning I can order for breakfast. I am the only customer. I can order for breakfast. Afternoon I can order for lunch. Night I can order for dinner. That means with one customer record, three transactions are there or not? That means I have here customer table. One customer may do n number of activities. That n number of activities will be registered here. That means in dimension table, one record is mapped with what, sir? N number of records in the fact table. Correct or not? Correct. That's the reason we written this point. That point is each dimension row has many associated fact rows. AK Parker is one dimension row that is associated with two fact rows in the fact table. Correct. Next point. Dimension tables do not directly relate to each other. What does that mean? If you see this dimension, do I have direct join, sir? No. That is what I am saying. If you go for here, there is no join between these two dimension tables. Each and every dimension table is coming via what, sir? Via fact table only. That is what the one more property. Next point. All dimension tables are denormalized. What do you mean by denormalization, sir? If I say products table means product related entire information. Product related entire information should be available in the table only. That may be product type, that may be product supplier, that may be product subtype, that may be product price, that may be anything. Entire information should be available in a single table. That is called as what, sir? Denormalized. If product type is available in some table, product subtype is available in some other table, price is available in some other table, this product supplier is available in some other table, then these tables are called as what, sir? Normalized tables. Normalized tables. If product entire information is available in a single table, then it's called as denormalized table. So that's the reason I written this point. All dimension tables are denormalized. That is the reason our star schema is also called as denormalized schema, sir. Our star schema is also called as denormalized schema. Yesterday I given one point for reading purpose. For reading purpose, normalized schema is preferable or denormalized schema is preferable? Denormalized schema is preferable. Yesterday, while I am talking about this point, I explained this point, right? Yes or no? Denormalized schema is preferable for reading the data. Normalized schema is preferable for updating the data. With respect to what, sir? Performance. With respect to performance, we derived those 2 points. Now, that is the reason star schema is also called as denormalized schema. Next point. It is optimized for what is the purpose, sir? To read the data. That means to execute the select statement. Writing the SQL query select statement is nothing but reading the data. In our SQL queries, we have so many things: insert statements, update statements, delete statements, create statements, delete statements. So many things are there. These all things it not support. It supports only what, sir? Select statement. Next two. It is user friendly, easy to understand. What does that mean? Suppose I developed the schema, I resigned my company, and I went some out of company. Someone came into the picture. In my place, someone will work right. That guy need to understand whatever I done or not. You need to understand whatever I done. Then it should be in a easy fashion. Means we require star schema. That's what I am saying. It is a user friendly. If it is available like this, means you come to understand. Okay, this is available. This is a fact table. These all are dimension tables. In this one, I have corresponding to sales revenue. Units sold, units shipped by customer. What are things I have in customer with respect to those all things are storing here. With respect to product, sales revenue, units sold, units shipped by what's that? Product are storing. So everyone come to understand very easy to understand. Are you clear, sir? If I follow star schema, it is very easy to understand and it is user friendly. Because if I say product table means blindly we have only one table. Customer table means what, sir? Blindly we have only one customer table. If I say let us say time table, blindly we have what, sir? Only one time table. Instead of that, products means I have let us say 20 tables are available. How difficult is understanding? We need to understand which columns are available in which table, where is that available, what is the primary key, how we need to give the giant. So many things you need to understand. Instead of that one, instead of 20 tables, you have only one table means always understanding will be very easy or not? Yes or no? That's the reason this point came that is called as user friendly and easy to understand. Next point. In OBIEE, BMM layer, only star schemas are used. BMM layer is one of the layer in our RPD. It is called as BMM layer, business model mapping layer. I said clearly in our OBIEE we are going to use 100% what, sir? Star schemas only. If you want, you can see this is the fact table, right? Right click and go for business model diagram, whole diagram. What are you seeing, sir? This is the screenshot I given in my document also. This is the screenshot I given in my document also. Sales facts. Next what's that? Products, times and customers. Am I clear? Right. What I am trying to say is in our OBIEE 100% we'll use what's, sir? Star schemas. Perfect. Next one, this is the star schema example, means looks like this. Star schema fact table. What do you mean by fact table? Fact table is the one which contains what, sir? Measures like sales revenue, units sold, unit shipped. The measures always in the format of what, sir? Numerics. Measures always in the format of what, sir? Numerics only is the central table in the star. Whatever middle available, the table I can say as fact table. Okay. Next one. What do you mean by dimension table? What do you mean by dimension table? Dimension table always contains what is the information, sir? Descriptive information. That may be sometimes alphanumeric also. Alphanumeric means 1 2 AB. Okay. 2 3 BX. Something like that. Okay. Next, here I have customer, means I have name and address will be there. Next, I have program, means program name and program format. Time means month, year, quarter, like this will be available. Product means product name and product line of business. These all things will be available. Anywhere do I have any measure column, sir? No measure column is available, right? No measure column is available. Let me go for next one. Example of star schema. Example of star schema. This already we discussed. Next, user friendly also we discussed. Next what, sir? Snow-flake schema. Before going for Snow-flake schema, let me recall one by one point what we discussed in the star schema. First point is what, sir? In star schema, fact table is available in the central and surrounded by what, sir? Dimension tables will be there. That is first point. Second point, each and every row in the dimension table, each and every row in the dimension table will contains many records in the fact table. Will contains many records in the fact table. For example, you can take customer table and sales table only. I am a customer, I joined in one hotel, I can order morning, breakfast, lunch, dinner. 3 records are available. Third point. What is the third point, sir? No two-dimension tables will contain direct join. Okay, no two-dimension tables will contain direct join. Fourth point. In star schema, each and every dimension table is denormalized. That means product related entire information is available in single table. Customer means customer entire information available in customer table. Okay, everything is denormalized. That is the only reason sometimes star schema is also called as denormalized schema. Why we are using denormalized tables is denormalized tables are optimized for reading the data. Denormalized tables are optimized for reading the data. That means select statements will execute fast. That is what the fifth point. Denormalized tables are optimized for reading the data. Sixth point. What is sixth point, sir? It is user friendly. It is user friendly and easy to understand. Suppose you design and you went out of office, no issues. Someone will come and he will do for you. Okay, that is called as user friendly or what, sir? Next one, easy to understand. Last one, in our OBIEE, we have one layer that is called as BMM layer. In that one, we will use 100%. What type of schema, sir? Star schemas. Right, we understand those all things. Next, let us go on to the next one that is called as Snow-flake schema. Let me concentrate on the diagram first. If you see here carefully, I have here, what, sir? Is it visible name? D1 products. It is, I am reading this one, sir. D1 products, it is what, sir? D1 product subtype, it is what, sir? D1 product type. That means product type information is available here. Product subtype information is available here. Here what, sir? Products information is available. If these are not visible, I can take our RPD and I can show from there. Product subtype, product type, let us say products, let us say orders, customers, calendar, physical diagram. Now see this one. If you want to organize properly, I will organize as per my slide. Now this is as per my slide. Now if you see carefully this one, this is what, sir? Orders. Here product information is splitted among 3 tables, right? Can I say these 3 tables are normalized tables? Yes or no? Normalized tables, can I say these 3 are? If product related entire information is available in a single table, it is called as denormalized table. Product information, some is available here, some is available over there, some is available over there, is called as what, sir? Normalized tables, normalized tables. So in the Snow-flake schema, normalized tables are available. That is one point. Second point, can I say this is the extended schema? Can I say this is the extended schema? Previously, products total information is available in a single table. Now I am extending that one. It is extended schema. Okay, that is the reason it is called as with two names. Snow-flake schema is also called as extended star schema, or it is also called as normalized schema, Snow-flake schema synonyms are what, sir? It is also called as normalized schema and extended schema Perfect. Now let us go for the points now. Based on this one, some points are there. We'll go for that one. It is a normalized tables are used. It is what, sir? Extended star schema. Next what, sir? Two-dimension tables will be directly joined. In case of star schema, what happens, sir? No two-dimension tables are directly joined. In case of this one, yes, this is dimension table only, this is dimension table only. Both are directly connected. If anywhere two-dimension tables are directly connected, straight away close your eyes and you can say there is what, sir? Snow-flake schema. Now, next point. Like star schema, it has only one fact table. One like quality is there. That like quality is in star schema as well as in our Snow-flake schema. We have only one fact table is available. Right, that's what the Snow-flake schema meaning. Then Snow-flake schema, if we go for general terminology, this is what is general terminology I given. This is time dimension table. This is customer dimension table. Here what happens, sir? It is geography. In the geography, country information is available here. Region information is available here. City information is available here. Product information is available here. Brand information is available here. Color information is available. These all are normalized tables or not? Normalized tables. If you go for the next slide, I give some columns also over there. If I go for region, this is time. I have here what, sir? Month code, month name, quarter code, year I have. This is what, sir? Week code, week name, month code. This is month table I can say. This is year table I can say. This is day table I can say. If you go for the products, this product code, product name is available. Here what, sir? Brand name, brand code is available. This is what, sir? Color code and color name is available. So these three tables are talking directly or indirectly about product only. Yes or no? About product only they are talking. But some information is available in one table, some information is available in another table, some information is available in another table. That is the reason these are called as what, sir? Normalized. Perfect. Here if you go for the employee information also, employee region is available here, employee state is available here, employee city is available here, employee codes are available. This is what is happening. These are called as normalized tables. Right. Next one. Third one is what, sir? Mixed schema. Mixed means in the name itself we have the full meaning. Mixed means what, sir? Both. Combination of star and snow. Okay, right. If you go for mixed schema, galaxy schema or mixed schema, both are one and same, sir. I mean to say, if you say constellation schema or mixed schema or galaxy schema, three are synonyms. Galaxy schema or constellation schema or mixed schema. Galaxy schema contains many fact tables with some common dimensions that are called as conformed dimension. Before going for the points, let us observe this diagram. If you observe carefully, whatever I colored this one differently, brinjal color, the brinjal color is called as what, sir? Fact table. Remaining things are called as what, sir? Dimension tables. If you closely observe, this fact table and this fact table are sharing this dimension table or not, sir? Time is the common dimension table for this table and that table. What do you mean by conformed dimension is a dimension table is shared by two or more than two fact tables. A dimension table is shared by two or more than two fact tables. Then it is called as conformed dimension. Now, as this time table is sharing by this table as well as this table, so it is called as what, sir? Conformed dimension. Similar to that one, products also shared by this one and this one, right? So this also called as what, sir? Conformed dimension. Now if people tell me, to form the mixed schema, we require conformed dimensions or not? We require conformed dimension. Without conformed dimension, there is no mixed schema. Without conformed dimension, there is no mixed schema. I also can say internally one more point here. If you assume like these three tables are not available, remaining these five tables are called as one star or not? Remaining these five tables are called as one star or not? If you assume like these three tables are not available, these five tables are called as one star or not? Can I say in this mixed schema, two star schemas are available? Can I say in this mixed schema, two star schemas are available? One is sales star, second is what, sir? Purchase star. One is sales star, second is purchase star. Two star schemas or two snowflake schemas or one star and one snowflake schema, any combination it is called as what, sir? Mixed schema. Any proportion of combination is called as mixed schema. That means n number of star schemas or n number of snowflake schemas or some stars, some snows is called as mixed schema. Most of the times we'll go with the mixed schema type, sir. Of course, internally in mixed schema, what we have, sir? Star schemas only we have. There is reason star mixed schemas will go. What is it, sir? Star mixed schema. That means that mixed schema is developed using stars. I said predefined one database will given by the Oracle. That name is OBIEE, I said, right? Oracle Business Analytics Warehouse, I said. In Oracle Business Analytics Warehouse, what that guy given the database is, all are conformed dimensions only. I mean to say, sales is one fact table, loyalty is one fact table, finance is one fact table, inventory is one fact table. These all four tables are sharing what, sir? Time table, product table, customer table, all things. That's how we design. I will show you whenever I am discussing OBIEE. Again, I will show you the data model how it looks like. Okay, always anywhere if you go, standard method of following is mixed stars will follow, sir. What is that? Mixed stars will follow. Mixed stars is nothing but combination of star schemas. Am I clear? Here we understand one more point, that is conformed dimension. A dimension table is shared by two or more than two fact tables. That is called as conformed dimension. With this I completed data warehousing concepts. Now I am entering into our tool. What's the time, sir? 10:03. I'm sorry, 1 minute. Let me connect to my bridge call, sir, then I will discuss. Yeah, could you please connect to US bridge number? Exactly. 18, 19, 21. Healthcare. Thank you. Okay, this is the status call, sir. I compulsory need to attend every Monday and every Thursday. I'm going to disturb you 2 or 3 minutes. Okay, once I connected, my job is done almost. Okay, in between my portion is came, I need to contact. That's it. Okay, right. Next, we understand We understand till this point of time data warehousing concepts, Then we'll go for the history of this OBIEE, That means what, sir? How this OBIEE came to existence. Similarly, history of the data warehousing. Before 1970, there is no data warehouse. We have everything is file format. In 1970, they came up with the mainframes. In 1980s, they come up with the DBMS system. In 1990, they come up with the data warehouse. Similarly, OBIEE, how it came? We have one small company. That company is called as NKS company, sir. That guy developed a tool called as NKS tool. Thereafter, what happened is, this happened around 1998. It happened, sir. After that, what happened is, civil organization acquired the company called as NKS company. Immediately, they renamed the NKS tool as what, sir? Civil Analytics. Thereafter, in the year of 2006, Oracle organization acquired Civil and renamed Civil Analytics into what, sir? OBIEE 10G. So how many transactions are happened, sir, here? First, it is developed by NKS company. Thereafter, it is acquired by Civil. Thereafter, it is acquired by Oracle. That's how it came into the picture. Now, if you go for the different versions of the OBIEE 10G, it looks like this. OBIEE 101.330, you can remember very easily. 101.330, 10.1.3.3.0. That series came up to what, sir? 4.2. These many versions are available within the OBIEE 10G. And out of these all versions, at this point of time, any company is executing 10G also, then they will use either 4.1 or 4.2, sir. No one is using these all things. If they are using 10G itself is nowadays 40% of people are using, remaining 60% of people are using what, sir? 11G only. If they are using also, they will use either 4.1 or 4.2. Now, if you go for the next one, let us say OBIEE 11G versions. We have OBIEE 11.1.1.3. It is released exactly 2 years back, sir. In the June of 2010. It is released. And in point 3, we have so many bugs. That is the reason immediately after 4 months of gap, they come up with one more thing. That is what, sir? 0.5 version. At the time of 0.3, Oracle guy only strictly said, boss, don't migrate to 10G to 11G. We have so many bugs in that one. Let me give one more version. That's how we stopped the clients. That many bugs are there. Coming to the 0.5, yes, it is free of bugs. Everything is looking good in the 0.5. 0.6 version is released exactly 2 months back. And in this one, only one new feature is came to extra, sir. That is called as Exa Analytics. What is that? Exa Analytics. We have one concept in the Oracle database that is called as big data. What is that, sir? Big data concept is there. That big data, using big data, if you want to develop the reports, means our tool need to support. So they come up with one more thing that is called as Exa Analytics feature. That Exa Analytics feature is integrated in the 0.6 version. That is the only one difference between 0.5 and 0.6. Remaining all features are same. Am I clear? These were the 10G versions and 11G versions. Any questions? Oracle. It's the Oracle product, right? It's totally Oracle product. So that's the reason OBIEE full form is what, sir? Oracle Business Intelligence Enterprise Edition. Okay, totally developed by Oracle only. Okay, there is no outsourcing also. If you take any R&D cannot be outsourced. Internally, that is a product-based companies only, they will do that now. Am I clear? Right. Let me go for next one that is called as any reporting tool workflow. Let me take this one tomorrow onwards. We are going to start with our tool. Okay, don't miss tomorrow onwards. And also plan your schedule. 1 hour you are spending in my class means 2 hours you need to spend in the lab. hours you need to spend in the lab. In that way you need to plan and you need to come here. Already shown my documents and all. To practice those all documents, minimum you require 2 hours of time. Okay. If you are working somewhere also, no issues. Somewhat you need to make your laptops are working fine. Installation will be Srinivas will be helping here. Take help of Srinivas and try to install everything. Okay. And night time or sometime whenever you feel free, try to do these exercises. Without exercises, keep on listening to the classes also, no use, sir. No use. Okay? Right. Thank you.
Ram. Hi Ram.
Yeah. Who is this?
Hi Ram, this is Vipul. Yeah.
Yes, Vipul, go ahead.
Ram, what about how are we going to share the material and the
immediately we already uploaded in the common shares.
But I don't have the link.
No, we are going to share. We are going to share.
Okay.
Yes, we are going to share once the money everything is created.
Yeah, but I don't know how to pay the money. Nobody has reached out to me.
So 2 minutes wait. Hello? Sir?
Hello?
Sir, 2 minutes wait, sir.
Yeah?
Yes, Vipul, go ahead.